Hello everyone, my name is Umair Mansoob and I like to welcome you all to my presentation about Exadata implementation strategy. During this presentation, I will go through 5 implementation phases that everyone can follow to implement Exadata in their organization. These phases are analyze, migrate, enhancement, test, and cutover. Here is a brief introduction about me. I have been working with Oracle databases for last 12 years and been working with Exadata appliance since 2011. I am not an Oracle employee or represent Oracle in any way. Let me start with brief description of each phase and later we will discuss them in detail. Basically, each Exadata implementation should start with analyzing target databases and then move to migrating data using suitable migration methods. Once data migration is completed, look into implementing Exadata best practices to achieve extreme performance from your Exadata machine. Each migration should also go through multiple testing life cycles before the cutover. During analyze phase, target database or databases should be analyzed in details. Collect information like database sizes, application type, I/O throughput, and memory footprint. Then based on the analysis, make important Exadata deployment decisions like do you need to virtualize your Exadata machine or do you need to implement resource management or what will be your ASM redundancy level for your disk scripts or how big should be your FRA. Migration strategy should be discussed in early phases of Exadata implementation. Map out each database migration with a particular migration method like Golden Gate, export, import, or data guard. You should also inform business users and other stakeholders about upcoming migrations so they can plan for outage. High availability option should be discussed early based on SLA requirements. Testing is an important part of Exadata implementation. Make sure to discuss testing options with stakeholders. There are several methods to migrate databases to Exadata. Each migration method has its own pros and cons, so analyze them carefully based on your requirements. If you want to minimize downtime, you should choose migration method like DataGuard or Golden Gate. If you are planning to migrate from big endian to little endian, you should choose transportable table spaces or data pump. If you really want to take full advantage of your Exadata machine, you should look into implementing following Exadata/database features. For example, compression not only reduces your storage footprint but also improve performance. Partitioning will improve performance, provide you maintenance advantage and increased availability. Parallel execution will also help you with performance and same goes for properly caching tables to Exadata cache. Even though offloading and smart scan are enabled by default, make sure they are turned on and performing as expected. Exadata machine does a great job managing resources by itself, but if you are planning to use your Exadata machine as consolidation platform, you should look into implementing resource management through database resource manager or IORM. Regardless of Exadata, Oracle has two native compression types, basic table compression and OLTP compression. You will not get good compression ratio with basic table compression and it will not support DML operations. But you can get reasonable compression ratio with OLTP compression and it will also support DML operations. Please note that there will be some overhead and you will need advanced compression license to use OLTP compression. Exadata comes with its own compression called hybrid columnar compression. You can get extremely good compression ratio with hybrid columnar compression, but OLTP operations are not supported. Oracle has also provided a DBMS package to estimate storage saving in case you want to use HCC compression. Oracle support many types of partitioning techniques, including range, list, and hash. As I have mentioned earlier, partitioning can provide you with many benefits like better performance, high availability, and ease of maintenance. Partitioning will help you achieve better performance through partition pruning. You can also perform certain maintenance tasks like truncate a table, gather stats, or rebuilding a local index just for a particular partition. Hence, it will provide you with ease of maintenance and high availability. You can execute your queries in parallel to speed up your load. If you are not already using parallel query feature, you should look into enabling this feature. You can enable parallel query execution at object level, or you can use SQL hint. You can also let Oracle determine the degree of parallelism based on a set of criteria and some initialization parameter settings. This feature is called Auto DOP, and it will automatically parallelize your queries based on a threshold. The threshold is set by a data parameter called parallel minimum time threshold. The default of this parameter is 10 seconds. If you want to run more statements in parallel, make sure to reduce that parameter so that more plan can qualify for parallel execution. Exadata comes with terabytes of flash cache. It is also called smart flash cache because it has an ability to move data in and out from cache based on usage. It is enabled by default and you don't have to configure anything to enable it. But you can turn it off or encourage caching a particular object by alter table statement. Write back flash cache provides the ability to write I/O directly to PCI flash, in addition to read I/O. If your application is write intensive and if one finds significant waits for free buffer weight or write bottleneck in the AWR reports, then write back flash cache is a suitable option. Exadata extreme performance is achieved through offloading and smart scan. Offloading means some of Oracle processes are offloaded to Exadata storage nodes. Oracle processes that can be offloaded to storage nodes are incremental backups, data file creation, decompression, and decryption. Oracle Smart Scan refers to an Exadata capability of performing projection and predicate filtering operations, which means storage layer will only return required rows and columns to database nodes, hence reducing I/O and network traffic between storage server and database nodes. There are some prerequisites for Smart Scan like direct path read and full table scan. So make sure Smart Scan is working for your database. If you are planning to use Exadata as your consolidated platform, you might want to look into implementing some level of resource management so that you can get consistent performance across different workloads and databases. You can use Oracle native resource management tool called Database Resource Manager to manage CPU utilization, parallel queuing, and long-running queries. And you can use IORM, which is an Exadata native utility to manage IO throughput and latency. Testing is one of the most important part of Exadata implementation strategy. You should have a test plan ready before you start the migration process. There are many types of testing you can perform during this phase, like performance test, break test, and failover test. You should at least test all of your critical processes. You can capture performance stats using tools like AWR reports, ASH reports, SQL performance analyzer, and real application testing. Compare captured stats with your baseline, which you captured earlier in your analyze phase. Also validate Exadata configuration through running Exacheck. Log and remediate any issues you encountered during this phase. You should carefully plan your cutover phase. Make sure you have performed backups and have a fallback plan ready in case you run into any issues after the cutover. Depending on the migration method you have chosen and the maintenance window, you might be required to sync your target database. In the end, I'd like to thank you all for listening to my presentation. If you have any questions or comments, please email me at umairmansoob@gmail.com.